Welcome to Interface. Today we have an eminent scholar and researcher and an academician in the area of GIS and remote sensing, Dr. Ramarao Nidamanudi. Welcome, sir.
Welcome.
So, he is from Indian Institute of Space Science and Technology, Trivandrum, and he did his M.Tech in remote sensing and PhD from IIT Roorkee again in remote sensing, and he got different postdoctoral degrees from Australia and Germany in the area of remote sensing and GIS. So, presently you are with ISRO Institute and Indian Institute of Space Science and Technology, Trivandrum. Sir, so what is the evolution of remote sensing in India and in a global scenario, and what is the present status of remote sensing technology in India?
As far as this Indian starting with remote sensing is concerned, India started launching first satellite in remote sensing in 1988 with IRS-1A as the first satellite, with a sensor called LIS-1, where the resolution is about 72.5 meter with 4 spectral bands with 7 bit radiometer accuracy. And that was the first satellite, in fact, launched from India's own spaceport in Sriharikota with our own PSLV launch vehicle. And that time it was in fact one of the contemporary resolutions in those days were having multispectral data about 72 meters with a repeat cycle of about 24 days. Then within few years, then it was followed up by IRS-1B, where the resolutions and other sensor parameters were improved upon, and the resolution became in fact 32 meters instead of 71, and same sensor configuration continued. And then by 1995, the resolution is actually much better, while the power of sensors improved dramatically. At the same time, globally there was some good achievement, particularly from French satellite, where they produced about 10 meters of panchromatic, what we call is black and white picture. In the remote terminology we call panchromatic sensor. They actually could launch one spot with a 10 meters resolution. That time we came up with the IRS-1C. In fact, ISRO made this satellite with containing the same LIS-2 become LIS-3. There the resolution actually was much better compared to 32 meter. It again come down to about 23 meter, and there we included a new panchromatic sensor with a 5.8 meter resolution. That was one of the best spatial resolutions available at those times, and it continued, followed up by another mission called IRS-1D in 98. And since then there have been several space launches, both remote sensing, improving upon the existing resolution and catering into a new domain of applications such as ocean applications, atmosphere, and also weather. So, in addition to high resolution land based remote sensors, which are like panchromatic and LIS-3 based imaging, a new series of sensor called ocean color monitor was also included, where it could have very high resolution data, particularly monitoring the color of ocean chlorophyll producted. All those applications were actually started getting enhanced importance those days, and that was followed with a mission called IRS OceanSat-1. And then there was much more improvement, where these same land based sensors, ocean based sensors included in another mission by putting another wide field of view sensor, where you can improve the acquisition of data over a short time. So, compared to some 24 days of LIS-3 high resolution data, you can have a perspective of entire globe or India as a small set of images within less than 5 days of revisit time. So, that has been followed by many missions, and during 2002 and 2003 there has been tremendous improvement in civil as well as military applications, where some of the sensors were actually launched exclusively for defense purposes, where even during the 2001 India actually launched a sensor with 1 meter capability. While that was the time where private players in abroad, they actually offering commercial versions about 1 meter resolution, and that was best available for anyone to buy. Whereas we had that kind of resolution data, but for some time it was given for defense, but later on improvements were made, and the very same resolutions were actually made even for civilian with a satellite name called Cartosat, where 2.5 meters of stereoscopic data was actually made available in that sensor, and that was one of the best configurations those time. And continued that in the multispectral front, the 23 meters now again actually came down to 5.8 meters.
That is the present.
That's the best resolution in the multispectral camera, and we can still have the same kind of configuration with a little more improvements made in the list 3, and the present suite of sensors where we call land based remote applications. For example, the recent resource SAT2, all these list 3, list 4 and wide field of view, which again have got some improvement in terms of resolution. Earlier it was about 180 meter, now it become actually 56 meter, while the radiometry was much improved compared to 7 bit, now it become 10 bit. And in addition to that, there are also possible application atmosphere, ocean and global monitoring also now possible with all the remote sensor. In addition to these all terrestrial based remote sensor, there have been few efforts and success in even the planetary missions as well. We could see that Chandrayaan was also made it. So, where this as a capable remote sensing instrument with a different kind of applications, including surface mapping, mineral composition, all things are actually possible with Indian missions. Now, compared to the contemporary capabilities and available to sensor, India is one of the very few national levels nations where a suite of remote sensing satellites are there, and which can have a constellation of satellites in themselves. In that way, I think it is none second to anybody. It is fine doing.
Okay. So, that is a very valid information that India is far ahead among other countries compared in this area of remote sensing, right. Sir, this is a fascinating world of satellites. So, what is the different type of satellites available presently to handle different applications in remote sensing?
As far as the different type of satellites are concerned, we can broadly put into two categories where we call passive remote sensing satellite, which depend on solar radiation. Another kind of satellite is actually active remote sensing, where satellite will have its own source of radiation. So, it illuminates the targets and captures the data. In this passive remote sensing satellite, which are actually the common domain of remote sensing, right from the beginning of remote sensing, this passive or the normal mode followed. There you can say two kind of subdivision. One is very high spectral resolution satellite, and another very high spatial resolution. So, as far as spatial resolution concerned, starting from 70 meter, which 72 meter, which came on Landsat 1 1972. Now, 72, 32, 20, 10, 5, 1 meter, and now it came actually 30 centimeters.
Oh, great.
And that is the capability reached as of now any remote sensing satellite. So, exceptionally improvements in terms of resolutions. And then many times what happens is, merely having very high spatial resolution would not complete the picture. Sometimes many things are actually observed from their properties, how they interact with alchemy radiation different spectral band, where the spectral resolution also an important ingredient to to make any kind of wild observations and measurement. In that case, starting from few bands, about 4 to 5 bands in the multispectral domain, a very discrete thing, it had been improved from 3 to 5 to 10, 30 bands with mode sensor. Now, where the case is that we have had more than 220 bands and space-bound satellite at 30 meter resolution. That is what we call very hyperspectral remote sensing sensor, where much have been improved. This is the improvement that made in terms of optical domain or passive remote sensing satellite. And another domain of this remote sensing is active remote sensing, where we can again make into two categories. One is this laser scanning, another is microwave scanning, microwave remote sensing. So, this microwave remote sensing is like having a microwave radiator which emits a microwave radiation, illuminates a target and records its return. It is much like a radar kind of principle. Advantage is that when we look at it, optical remote sensing data is only possible where atmosphere is friendly to you, in the sense it will not come your way. If there are any clouds, any rain, then there is no possible that you get data in a optical domain. But if you see most of these tropical countries, including 80% of India, clouds are all going to be there always in entire monsoon season. So, even though having very high resolutions and capable optical sensor, we cannot get data which is cloud free. That can be actually circumvented by this microwave sensor, where this microradiation is not that much sensitive to atmosphere. It can penetrate. It can be used during entire day and night. So, if we like to have any imaging done or any observations made, including floods or any kind of transient phenomenon, actually microwave complement that kind of capability. It will give you data. And where now the present scenario of microwave also excellent possibilities are there. And in that front also there has been a significant improvement in Indian capability to have a civilian microwave sensor that we call recently RISAT-2, where radar imaging satellite from ISRO, where the spatial resolutions of the radar imaging satellites are actually quite variable. We can get as best as 5 meters and as moderate as 50 meters from the same satellite. That is another already there. And globally they have been several countries making it, and a few companies, private players also having that, and systems are good. And another category is what we call is LiDAR remote sensing, or in general we call them laser scanning, where the same principle used for radar remote sensing here used. The only difference is that instead of microwave radiation here is going to be a laser. Here the scanning is done in a such a way that actually you can fill the entire area of a view of the satellite with the points. So that the entire 3D information of any target of interest or any area is actually captured, where you could able to find the geometry and rich spatial information of the thing. And like microwave satellite, this laser scanning also independent of atmosphere. So, in fact, night time is more better than daytime. So, these are the 4 categories and which made it, and the resolutions are as of now exceptional. Microwave about 2 meters is possible, and laser scanning 60 points per meter square is now is going on.
So, it is very interesting. You talked about the spatial resolution and the spectral resolution, and you are talking about the very high resolution images, right. So, my interest is, so how can I get the data for a research or academic purposes? So, which agency is providing this high resolution images, remote sensed images for a academic institution?
For an academic perspective, where research, for example, doctoral research or master's undergraduate research is concerned, or even an individual faculty research, where a key formal project is not anything. Actually, there are several places where different types of data, all kinds of data, microwave, laser scanning, optical, in fact, in thermal, all kinds of satellite images are there, which actually we can download for free. And for just to give you an example, if we look at our Indian satellite data ranging from list 3, list 4, even wide field of the sensor, where you can get data at 56 meters, 23 meters, even 5.8 meters, we can actually download the data for few dates for any region in India, including high resolution digital elevation model that was prepared actually from Cartosat data from a web based 3D portal called Bhuvan. That Bhuvan is now being hosted by NRSC Hyderabad, where actually we can register ourselves and we can download for free
Oh.
about India. On the other hand, as of now we have no provision for other kind of data such as laser scanning, but there are several online resources, for example usgs.gov.in,
Okay.
where we can actually download satellite data of most of the foreign agencies, including laser scanning data.
Okay.
And those data sets many times also come with very high resolution ground truth data.
Okay.
So, if research is there and the study is not based entirely on a specific site in India or elsewhere, then there is no limitation as such. You can have the data set downloaded and you can analyze and you can validate them with the available ground truth image that they provide. So, that is there.
Okay. So, could you please explain the image processing techniques that we normally apply in the remote sensed images? How we can process the images for a particular application? Suppose we want to identify the water bodies from the remote sensed images, or the vegetation, different type of vegetation. What are the normal image processing techniques that we can apply on this?
In general, there are two ways that we can actually process any kind of remote sensing or satellite images for this kind of application, that including not only vegetation, water, but any kind of surface based land surface based features and covers mapping and monitoring. There are two categories that we can put. One is a generic analytical perspective, where you are going to analyze the entire image based on some kind of techniques. So, irrespective of your own interest of only one kind of land cover, you can actually identify and map all the available land covers in an image. In general, the normal procedure followed is supervised learning, where within you will be having some known data samples within particular image, and you are going to deploy a kind of a supervised statistical classifier, which actually models the properties of different land covers available in the image based on the references that you provide. So, once that particular classifier is trained with the sample data, it could actually detect and label each and every point in the image, each and every pixel in the image. So, at the end of it, you are going to get your entire area as a classified. So, within that you can have a further filtering of whatever land cover that you like to have. That is one generic process. But as I mentioned, there are some cases where resolution of your satellite plays an important role on what kind of method you are going to make it. And then if you are looking for a specific case of say water bodies monitoring, then there is a little different approach we follow. For example, every material has a different interaction mechanism with electromagnetic radiation. Take the case of this water body. Pure water, if it is pure, it has the tendency of absorbing all the near infrared radiation, and it reflects to a certain extent in the visible radiation. So, its nature is that you will have got reflectance received in the visible, for example, in blue or green wavelength, and near infrared radiations, for example, about 1.1 micrometer, it would not retain any reflectance at all. So, if you take a ratio of these two bands, so one in blue, another is near infrared. So, ideally, if near infrared very less and blue is very high, you will get this ratio as a big number. So, you will have got a number that indicates the presence and quality of water. So, on the other hand, if the water is say not pure, turbid, infested with trees or some kind of any other impurity, then the near infrared radiation actually increases its reflectance. In that case, this near infrared will have return signal. So, your ratio of blue to near infrared will be less. So, based on that kind of index, what we call a spectral index, you can have a quantitative way of mapping a water pixel in any area, and this can be fairly automated as well. If you still like to have a full fledged and automated way where you would like to have homogeneity also maintained, then deploy this kind of water specific spectral indices with a normalization procedure, followed by a kind of small morphological operations, so that any breaks, sudden breaks, are taken care of, then we can actually get a kind of automated method for water body detection. Similarly, vegetation is a detection also like that, where vegetation characteristic feature is low reflectance in red because this chlorophyll absorbed, and a very strong reflection in near infrared. So, at about 750 or 790 nanometer, vegetation reflects more than 60%, whereas at the red band between 650 and 680, its reflectance would be only order of 5 to 7% in healthy vegetation. So, if you take a ratio of these two, you would get quite big number. So, near infrared divided by red. So, that indicates the presence of vegetation. So, if you take this ratio, apply this band combination and compute it, wherever vegetation is there, it is going to be a positive number and bigger number. As vegetation comes down, so soil dominance will be more, soil will also have equally strong reflectance in visible. So, your number becomes less, and that is indication of low level presence of vegetation. Similarly, some of these things can be actually automated, where you can have a first to second level of mapping done in automated way.
So, sir, GIS is another application area, so closely related to remote sensing, geographical information systems. So, you might have worked on this type of projects, right? Could you please explain certain projects that is used for environmental planning or infrastructure planning, or making decision support system based on the GIS platform?
GIS is one of the key platforms, technology and database platforms, which actually is an system itself at the same time, which is part of any remote sensing based system. As the name suggests, geographical information system, any data that has a relevance to location is captured, processed and recorded in a software platform, in database platform, where you can analyze the data in such a way that you can model anything based on anything. For example, take the simplest case of water quality. Water quality is often decided by, if it is a urban body, the land use, present land use, and much of urban sprawl, and how much of actually waste generated per day, what is the mechanism, where are the places of solid waste dump. All these are different places of different parameters that affect your quality. So, if you have got a spatial map of these layers, say waste quality, waste dump areas, map of waste dump areas, urban sprawl areas, and addition to water bodies location, actually you can analyze how much is the contribution of water quality deterioration from the waste dump at a particular location X. Similarly, you can also perform a kind of overlay analysis, such that what is the population pressure that actually affects this kind of solid waste dump, and in turn water quality. So, the existence, quality and its dynamics can be easily actually modeled in a GIS platform, because you will have the data of various type of parameters as a spatial reference at the GIS layer, and all can be integrated and put into a model in such that you can actually simulate, measure and map any parameter based on this your data. So, that is all possible in the GIS system. And in this connection, remote sensing, where satellites and other imaging data sources are one of the prominent sources of data that you require. For example, if you like to know how much of urban sprawl is there, and where is the buildings and where is the open spaces, that you can get from the satellite data analysis. So, once you analyze satellite data, convert that into a GIS database format, and you can import into GIS system. So, that serves as a standard database for it. So, many times GIS is well integrated with the remote sensing data sources, and this can also accept data from any point of, including non-spatial data as an attribute data, that explains further what happens if this kind of data are there. So, these two are actually complementary, where the power is much higher if these two are well taken care of.
So, it is also very interesting, you have mentioned many applications. So, suppose we are looking for a application which integrates the remote sense data for precision agriculture. Suppose you have water bodies, and what is could you please explain the possibility of exploring the prediction? Suppose you have a data of a period of time and about a water body or a agriculture land. So, is that possible to predict what will happen to this body or water body, or that type of application is also already available?
Actually, that is quite possible.
Okay.
And we can also actually what you call is modeling,
Okay.
a kind of modeling and simulation, where if you just refer to these water bodies and precision agriculture, reason is many of these things are affected by many parameters.
Okay.
And if you have got the data, for example, soil, nature of soil, local geology, and drainage network, all the streams, their network, where they source and where they end up, and their proximal other land cover, actually we can easily model and predict what is the area, extent, dynamics and quality of all these water resources over any point of time. You can actually predict in future with a well defined parameters of interest, with reliable estimates of all the parameters, and also we can actually back predict.
Okay.
We can actually simulate this with a very precision what would have been the condition of these water bodies about some time back.
Okay.
That is possible. And as this present status is easily available from any high resolution remote sensing data, and that can be integrated with GIS data. And if we have this data of, for example, local land use, soil, water, geology, drainage network, actually we can have a very good land use modeling done, which we call prediction models and integrated assessment model. In these integrated assessment model, you can actually model any system, and you have the flexibility in addition to catering to immediate requirement. You can actually assess a scenario based.
Okay.
For example, you can think that what happens if this particular area become forest. If the present land use say urban, suddenly their forest has come. So, how that particular change in the land use is going to affect your water resources in terms of their area, quality and its future dynamic. So, we can actually visualize and predict with a statistics and map very well. That is possible. That is there in, that is actually the real power of this GIS data system.
Actually, so what are the research institutes and programs or academic programs that supports this remote sensing in GIS?
As of this remote sensing in GIS, from academic training is concerned, most of these central organizations, they have this master's program already running. Many MTechs in geoinformatics, or some university called photogrammetry remote sensing, or some university called geomatics. Different, despite small change in title, all can be generically called as remote sensing GIS. About 5 to 7 IITs and more than 10 NITs are actually offering master's program in geoinformatics.
Okay.
That apart, in every state we would find at least 2-3 institutions, universities, state universities offering master's program. Some of those divisions could be in the environmental, some in the civil engineering department and some in geography department, but it has established itself as a full-fledged academic field of study, and where masters and doctoral programs are very well integrated and well defined. So, there are several institutions, including few private institutions such as SRM, Symbiosis institutions, which offer masters and PhD programs in remote sensing GIS. So, this well established field of study now.
So, this is a interdisciplinary research area.
Yeah.
So, what is the basic requirement to enter in the field of remote sensing in GIS?
Basic field, yes, as you rightly mentioned, it is interdisciplinary. Anyone after +2, in fact, can think of spatially.
Okay.
Anyone who can think any time a spatial visualization.
Okay.
What happens if it is a space? What happens if this is a land? that will be a starting ground. So, that said, though as of now at undergraduate level, particularly in the traditional domains such as BA, BSc, it has not been part of the curriculum, but at the professional levels where BTech Civil Engineering, it has already been a part of the curriculum. So, at the undergraduate level itself, it already become part of it, and all the universities or institutions which offer BTech Civil Engineering, they have got these 2 papers, at least minimum 2 papers of GIS, remote sensing and 1 satellite image analysis courses already become part of it. So, right from undergraduate is already started, and that is the best time also to start with. And as it is a cross disciplinary, one can become a specialist in one area of interest, for example, in geology, environmental science or geology or geography or any kind of forestry, agriculture. At the same time, becoming familiar with studying it and having a working level knowledge of remote sensing GIS is actually very crucial, and nowadays a systematic study of these any of these scientific and engineering field is not possible without having resorting to use or try to use of these remote sensing GIS tools and data sources. So, that is already well integrated. One cannot escape out of this. Such an important tool it becomes.
Yes. As this has become a promising technology, so we have many real life applications in the present scenario. We have navigation applications, we have mobile applications, so we have many open source tools available. So, what will be the future of this GIS in India?
The future of GIS is started from a modest beginning for a research tool, and then slightly at a lower level of national level broad mapping of natural resources and a case studies. Now, thanks to the technologies, mobile computing and imaging capabilities, these remote sensing GIS become an important that it is actually replacing some of the traditional fields of working. For example, until now we have got all the revenue records in terms of the simple cadastral maps, which are of some 100 years old or even old, where finding a proper identification or extent of a land is really impossible many times. Now, several state governments we actually started making all these land record a GIS compatible record, and if you see that every field with its cadastral boundaries, its location based on GPS coordinate, and true owner of that particular plot is going to be mapped with the GIS technology. And advantage that all these technologies are actually linked with mobile technologies. So, the situation now that on our smartphone we can actually see where our field is, if anybody owns some kind of piece of land, and what are its boundaries, and he can actually perform some kind of measurements as well. So, it already become part of practical tool, and that is about one land thing, revenue. For example, if you see our business, it has been already we have been using. So, every business enterprise like to see location, movement of resources and movement of the people as function of location and time. So, as GIS will able to give you location of any coordinate and any object, it lets you see where actually something is nearer to you and where it is what, how much time it takes to move one place to other. This data has been actually much more exploited by all the business enterprises to make business sustainable and profitable by using a smart way of GIS. And similarly, we have been now accustomed to the case of navigation, where every new car that we can buy, we like to ask whether this navigation is there or not. Very, very important civilian application of GIS and remote sensing and particularly GPS satellite is that we can actually very well show that where I am going to is the way. We can easily map in GIS navigation. So, that is one of the very comfortable and confident applications of these GIS and remote sensing technologies. And if we see the future, I think every instrument, electronic instrument, perhaps mobile and any device is going to have a small application of this GIS as a small server. so that you will be invariably using all the geolocation specific information for your own benefit.
Yes. So, no innovation is worthwhile unless it is useful for the masses.
Yes.
So, this is a promising technology. So, thank you very much for your time. Very interesting and informative talk.
Thank you. Thank you very much.